Welcome to Mr. Remove's class.
That's right, good job. All right, today, class, we're going to go over 2-1. And what is 2-1 dealing with?
Relations and functions.
That's right, relations and functions. All right? Now, any ordered pair is a relation, if you were here with us yesterday. If you weren't, you're watching the wrong video. You want to go back a video, all right? So, right here, what is the definition of a function? Each x value can only have one corresponding y. Bless you, y value. That is correct. So, let's think about this. There's an x value, there's a y value. There's an x value, there's a y value. See a pattern here. It looks like each x has only one y value. So if I said, is this a function or not a function, you would say, yes, Mr. Dude, this is totally a function because each x has one y value. Now, if you read the bold instructions on your assignment, it says this. Ready? I'll read it for you because you guys can't read it. You can read it, but people watching the video, they can't read it. All right? Yeah. Determine whether each relation is a function. Well, we did that. Write yes or no. We did that. If the relation is not a function, justify why it is not a function. So, we only have to justify if something is what? Not a function. So since this is one, we're not going to justify. We just know that it is. So let's go over here to number 2. See if we need any justification. Oh, I see Jordan. She's nodding her head. She's like, yep. So, you're going to say, Jordan, you're going to call this one what? No. This is definitely what? No. Right. Not a function. However, can you give me some justification? What caused you to believe that this was not a function? Say it again. Say it louder. The input of 3 has more than one. What do we call these? We can call these y values, right? So this x value is now leading to two different outputs, all right? And how many outputs are you allowed to have? 1, not 2 for the same input. All right, so we're going to justify this, all right? Jordan said 3 has 2 different outputs. Okay? There's many ways you can justify it. Okay? If you want to say this x value has 2 different y values, you can say that. That's great. 3 has 2 y values. Perfect. I like it. I accept your response. Okay? So, remember, domain means the set of all of your x values. Range means the set of all of your y values. Just a quick little review. Now, that's what you're doing with the max right there. Okay? Well, what do you do with a problem like, say, number 5? Number 5, we have a picture of a circle. And we have to ask ourselves, is this a function or not a function? Now, when you think circle, that's something you think about, like that's part of real life all the time. So it's something that makes sense to you, right? So you're kind of leaning towards it. It's got to be a function, right? But it actually isn't. So, go ahead, say it.
The bottom of the circle crosses it, so it would have, oh my gosh, that's long.
That's okay. Okay, how about this? Let me give you a hint. Ready? There's a certain test we can use on a circle. By the way, what am I drawing through this circle that's piercing it all the way through? What kind of lines? They are parallel. Straight up and down, but there's another mathematical way of saying straight up and down. Oh man, at least I wasn't.
Oh man.
But that's okay. That's okay. These are all what? They're all vertical lines. By the way, what test am I doing right now?
The vertical line.
That's right, the vertical line test. This is awesome. You guys are doing great. The vertical line test. Being the pencil test. Well, we're going to call this the vertical line test. Okay? Being the pencil test. Now, here's what the vertical line test tests. It tests, does this pass through more than once? You're like, well, yes, Crosses through this what? Twice, everywhere, right? That's stop. Now why is that important? Here's why it's important. I don't know what this x value is, Jacob, but I know that this x value is the exact same as this x value, but they have two different y values.
Yeah.
So, like, for example, I'm going to go over here and change. Like this x value right here, hold on. Oh, not that way. This x value right here, would you guys agree that this has an x value and a y value for this point? But this x value down here has the same x value, but the y value is going to be some negative version of, some negative y value. And no, I don't mean it's the exact opposite. I'm just saying it has a y value that just happens to be negative. Okay? That's how the vertical line test works. If it crosses more than one point, it lets you know it's the same x value, but you have different y values. Now, remember I said justify? Here's your sentence for justification. Ready? Think of Campbell. It does not pass. Right? Thou shalt not pass. It does not pass the vertical line test. So there's your justification for problem number 5. No, that is not a function. And why? Because it does not pass the vertical line test. Okay? So that's what you guys are doing on the first 9 problems. You are either saying, yes, it is a function, but if you do say, no, it's not a function, please justify your answer. All right, problem number 13. We're going to read in bold what we're supposed to do for problem number 13. Says, graph each relation or equation and find the domain and range. Next, determine if the relation is discrete or continuous. Then determine whether the relation or equation is a function. So what we're going to do is we're going to graph these points right now. That's the first thing we're going to do. Okay? Let's graph these guys. We've got a -3, 4. So we're going to go over -3 and a 1, 2, 3, 4. We're going to put a point. Then it says -2, 4. So go -2 up 4 for the point. -1, -1, -1, -1, -1. Put a point. And finally, over 3 and down 1 and put a point. Now, I'm not asking you to connect the points, okay? I'm just asking you to plot them. And yesterday, we learned that the difference between discrete and continuous. Continuous, something that's continuous, everybody, is something that kind of just goes on forever in both directions. Like a continuous, either curve or a continuous line. It doesn't matter which direction, it has to be going forever. So this is definitely not continuous. So if it's not continuous, it's discrete. So one of the ways to describe this, and this would be a discrete. Now, discrete what? Is this a discrete relation or a discrete function? Now, remember, a function, each x can only have one y value. So it is, remember how we talked about the vertical line test? Would this technically pass the vertical line test? If you took a line, it would, right?
Yes.
Okay? So being that it passes the vertical line test, this is what's known as a discrete function. Okay? That's one of your answers that I'm looking for. Okay? Labeling it, not just whether it's discrete, not labeling whether it's a function, but whether it is a discrete function. Okay? So here's something you can put on your paper. Remember, you're going to have the word discrete, or it's going to be continuous. You can kind of write this down. It's going to be discrete or continuous, and it's going to be known, whatever you plot will be known as a relation, or it will be known as a function. So it's a combination of one of these with one of these. Does that make sense? I know if you're listening to this, you can't answer me. I won't be able to answer you if you say that. Yes, it does.
No, it doesn't.
Yeah, I won't be able to help you. All right, I'll come say hello. All right. Oh, the other thing I said what? Tell about the domain and the.
Yeah, just find the domain.
So here, put D for domain. Okay. Put R for range. And remember, domain is the set of all of your x values. So what I'm going to do is I'm going to highlight all of my x values in blue. Also known as blue. all of my x values. So it looks like I have a -3, a -2, a -1, and a 3. So what we're going to do is we're just going to transfer this down. So my domain, the set of my x values is -3, -2, -1, and 3. And you close your set, because that's the set of all of your x values. Then we look at my range. Scroll back up. I'm going to highlight my range in red. 4, 4, -1, -1. Now the cool thing about labeling your domain or the range, you don't have to like repeat numbers. So I don't have to say 4, 4, -1, -1. Alright? I like to put things in order. So I'm just going to say my range is a -1, 4. That's my range. So we have answers, okay? One of your answers is a correct graph, right here. One of your answers is the correct label to what it is. And the third answer is the domain and the range and getting those correct, right? Pretty easy when you're doing dots. Let's do one that's actually an equation. So look at number 12. Let's go backwards, just for fun. What I'm asking you on number 12 is exactly what I'm asking you to do on all the other ones, okay? So look at this graph. It says what? Y equals x squared minus 2. All right, so you can go to your graphing calculator right now. Hit y equals. Type in this graph right here. I'll do the keystrokes. Here we go. X squared minus 1. Just like that. X squared minus 1. All right, hit the graph. There's your graph. That's the graph you're going to put on your paper, but you can actually plot points that will actually work. Okay? So, interesting. See if the table pops up. Hey, there we go. Wow, can't see anything. So much for that. Get rid of that. Let's go to the table. Second graph. So what I want you guys to do is make a little table on your paper right here and include these points in your table that you can actually plot. Okay. So if you check your table, you can plot these points right here. So I'll make a little XY table right here, right here. We had a -2, -1, 0, 1, 2. We went 3, 0, -1, 0, 3. So there's your table that you can use points to plot the points. But you guys notice really quickly when I hit graph, what kind of graph did you see? Discrete or continuous when you look at it? Was it a whole bunch of dots, or did it look like a nice solid curve? So that would be continuous. Very good. So we're going to plot these points just to give us parameters to go through. So we have -2, +3. We have -1, 0, 0, -1, 1, 0, 2, 3. And then you can just connect points. And why are we allowed to connect through the points? Because this is not a series of dots, right? This is actually an equation. So you're graphing an equation that looks like this. So now that you have that done, you're correct, this is continuous. We're not continuous. Does it pass the vertical line test?
Yes.
That's right. It does pass the vertical line test. So this is a continuous function. So there is our graph. It is a continuous function. And then here's the kind of the tricky part. What do we have to talk about? The domain and the range. D and R. Now, the domain once again refers to the set of all of your x values. So what x values do you notice that are being plotted? The correct answer is all of them. That's right. So if all of them are being plotted, you would write all real numbers are actually being plotted for all of the x values. That's the domain. However, there's only a certain number of y values that are being plotted. Okay? You notice where the y values kind of bottom out, where they like stop getting graphed? Where does it bottom out?